How you doing guys? Bioinformatics guy here with another video of the series Python for Bioinformatics. In this video, we will be talking about comprehensions, and specifically we will be talking about list comprehensions. So comprehension creates a set, list or dictionaries by evaluating a certain expression on each and every single value of another collection. Now this might get a bit convoluted at the moment, but once we start coding it will become very easy. So let's start coding. So we will start with the very basic double square brackets, and in the square brackets we usually create a list by 1, 2, 3 and 5. You can also create the same list by using a for loop like this, and you will write for I in range, and then you also have to initialize an empty list over here, and then you will be like a dot append, and then you will append it with I. This created a list with 10 elements. However, let me tell you this, that you can do all this by using just one line of code. So let's go to the new line here, and we will simply store our list comprehension in A, and we will do the same square brackets just like before, but you need each element. So we will say that element, and then you will have to apply a for loop over here. So for element in range, and then you will be like I need like 1 to 10, so you will type 10 over here. The same results like the previous one. So previously you were doing like 3-4 lines of code, now you've done like 1 line of code. Let's talk about how we can use list comprehensions in our function that we created in previous videos, and the name of that function was validate base sequence, in which we checked if each of the base is either according to the RNA code or the DNA code. Before we start defining our functions, let's just split this function into smaller chunks, and so that it becomes really easy to understand what's going on. So first of all, we will read DNA sequence. We will call it DNA sequence, or let's call it base sequence, and let's keep it ATGC TGCA. Okay, then we will create our RNA flag, and it's going to be false. Okay, come on. So, and now we need to check if each of the base is equals to our codon. So we also have to create valid bases and QCAG if RNA flag, else we will go for TCAG. Okay, and now we will do the magic of the list comprehensions. We will check base in valid bases, and then we will for loop base in base sequence, and then we can also change it to upper, so that even if you write small letters it won't give you an error. So if we will run this, what you will get, you can guess that in the comments. Either you will get bases or you will get true or false. I will pause it. You got it? And we will get true or false, because this base in valid bases, it's checking. It's going to return true or false for each of the element. So if I will change, like if I will change a non-DNA or RNA letter over here, like P at the end, then this last true is going to be converted to false, you see. And if I do the same thing with this one, it's also converted into false. Now we need to define a function, and we can do it in the next cell. We will define validate base sequence and we will give it our base sequence, and then we will also give it the RNA flag, which is going to be false by default. And yeah, let's move on to the next line, and we will need the valid basis simply. And after that, what we need is we need to return. Now here is the trick. We need to check all the bases, and if all the bases are from the valid basis, then we will use this all function, and this all function will return true if all of the elements of the list are true. And then we can simply copy this line and paste it here, and our function is ready. We ran the code and there are no errors, means that it's working just fine, and we can try this. And let me give it ATGC, and see, you got true. If you will put a P over here, you will get false. Now if you try to do this without this list comprehension, you will have to apply a for loop, and it will have become very lengthy and difficult. Now it's also very easy to understand. Next, we will use the function random base and random codons, which we defined in previous chapter, to generate a random base sequence. Those functions are repeated, so let me quickly define them over here. And we will have to import from random import randint, and then we will define random base, and RNA flag is going to be by default false, and then we will return UCAG if RNA flag, and else we will return TCHG. And then since we need a random base, we will use rand int. We will index it by a rand int, and it's going to be from 0 to 3. Okay, and here once first function is defined, let's go to the next one. Okay, I want to do it here, and def. Okay, def, and now we will have to generate random codons, and we will just do our RNA flag here, and simply we will call this random base function 3 times, and it will give us a random codon. Return, and this flag plus and this, and our 2 functions are defined. Now let's move on to our main function. Since we need to generate random codons between minimum length and maximum length inclusive, we have to give it like 3 parameters. So the name of the function is going to be random codons, and though the minimum length is going to be by default 3, and maximum length is going to be 10, and our RNA flag is going to be false by default. Okay, come on. Yep. And let's add a quick doc string over here, and this will generate a random list of codons, and obviously if RNA flag else DNA, and if it will generate a random list of codons between minimum and maximum length inclusive. Now you really don't need to worry about how this inclusive and exclusive things work if you just get confused. So you can keep on testing stuff in the terminal and you don't need to worry about it. Okay, so we will return, and this is going to be just one line of code, and previously it was like, I guess, several lines. So we will return random codon, 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 and RNA flag is and now we will apply a for loop for n in range, and then we will randomly generate a number for our list, for the length of our list, and it's going to be rand int, and it will be minimum and maximum. Okay, minimum and maximum length, and that's it. That's all the function. Let's run this. We didn't got any error. Let's go to the next line and try to call this function, and you got a huge error which says that random codon is not defined. I guess we have messed the spelling. Oh, it's random codons. Okay. This is supposed to be random codon, and this is supposed to be random codons. Let's read on this, and let's read on this, and let's read on this, and you got like 1 2 3 4 5 6, and next time you will run this, you will get a different length of list, and it goes this way. So that's all about list comprehensions in this video. In the next video we will be talking about set comprehensions and even dictionary comprehensions, and we can take this example a step further, and we already have a translate RNA codon function which we developed in the dictionaries video. We can use comprehensions in that function to simplify that as well. And if you have any questions, comments, or concerns about this video, you can always comment down below. I will be happy to help you out. You can check out the script of this video on the GitHub repository. If you want to read the articles, you can go to the Bioinformatics guy website. And if you want to join the community, you need help over there, you can join our Facebook group. And if you want to know what I do other than programming, you can check out my vlogging channel. Links are going to be just below the like and subscribe button. Thank you very much for watching, and I will see you around in the next video.